Hello, my name is Sarah Talui, and today I'm going to be presenting my physiological systems oral presentation for the University of Technology, Sydney. So my topic today is about these new lipids that aid in cornea healing. So before we actually get into the research, I would like to discuss the actual structures and the function of the eye. So the eye is basically the organ of sight. It allows us to see. So when light travels through the eye, it changes and transforms into an electrochemical impulse, which is then directed through the optic nerve to the visual to the brain, to the visual cortex of the brain, which is where we comprehend what we're actually seeing. So let's get on to the actual structures of the eye and go into a bit more detail about those. So the first layer is the fibrous layer, so it's the outer layer. This contains the cornea and the sclera. The sclera is the white of the eye. It's made of collagen fiber, so dense connective tissue, and it protects the eye, also giving it the round shape and rigidity, as well as anchoring extrinsic muscles to the eye. Next, we've got the cornea, which we're going to focus a lot more later on in this presentation. The cornea is a curved, transparent coat of tissue, and it covers the iris and is the first refraction point of light. Next, we've got the vascular layer, which contains of the choroid, ciliary body, and the iris. So the choroid, shown in my diagram here as that red section in between the blue and the yellow, lines the internal surface of the sclera. It is highly vascularized, so it has a lot of blood vessels and provides nutrients to the retina. It also contains melanin, which is it has dark brown appearance and absorbs stray light. The ciliary body is a thickened ring of tissue. It surrounds the lens and anchors a portion of the choroid. Additionally, it helps. The main function of it is to help change the size of the lens for distant or short vision. Next, we've got the iris, which is composed of a smooth tissue muscle. It contains the pupil, which opens and closes, allowing different amounts of light to enter the eye. Next, we've got the sensory or the neural layer. This contains the retina, fovea, and the optic nerve. So the retina consists of 3/4 of the back of the eye. It is a layer of tissue containing photoreceptors, so rods and cones, which transmit this light energy to an electrochemical impulse. There's the fovea, which is that little black section at the back of the eye. It is the highest point of visual acuity. It contains only cone receptors, and just to highlight, cone receptors are for daylight vision, so for light vision. It also allows us to see color, and rod photoreceptors are peripheral, like for peripheral vision and for night vision, so it only allows us to see in shades. The optic nerve that goes to the back of the eye transmits these electrochemical impulses to the brain and to the visual cortex of the brain. Okay, now I'm going to quickly go through how we actually see, so a step-by-step process. So when light reflects off of a surface, such as a tree or a table, this hits the eye, so it passes through the cornea first. The cornea refracts this incoming light, so it bends it. And then the iris regulates the size of the pupil, depending on if it's night or light amount of light coming into the eye. And then the lens also reflects this light onto the retina. So the photoreceptors on the retina, the rods and cones, convert this light energy to an electrochemical impulse, which is then sent up to the optic nerve, to the brain, to the visual cortex and the optical lobe, where we basically comprehend what we're seeing. Now let's go through the defense barriers of the eye. So the cornea and the sclera consist of the outer covering of the eye, so it's a protective region, preventing any infection from hitting the eye. So the cornea consists of 5 layers. So the first one, the outermost one, is the epithelium. So this is just a barrier for chemicals, water, bacteria, infections. So it prevents all of those from coming into the eye. It also contains immunological agents, so immunological cells, preventing the infections. There's the Bowman's membrane, which maintains the shape of the eye. There's the stroma, which is the thickest segment of the eye. It consists of 98% water, and it's like the mechanical strength of the eye, as well as giving the cornea the transparency and the main refracting region. There's the Descemet's membrane, which consists just of epithelium cells, and then the endothelium, which consists which is like the corneal clarity, and it removes water or excess water from the corneal stroma. Okay, now let's go on to the actual research. So corneal scratches is a very, very, very common injury. It happens to most people and can heal within a few days without any lasting implications. However, there are chances that it doesn't heal if it's like a deeper tissue injury, and this can cause potential irritation, pain, scarring, and in very severe cases, vision loss. So corneal wounds can result from a lot of different things. So it can be from like hitting your eye, like poking your eye with a mascara wand with your finger, vigorously rubbing your eye, wearing contact lenses for too long, having dust grains in your eye or sand in your eye, etc. And the cornea is a very, very, very sensitive tissue. So like we all have experiences. Like if we get an eyelash in our eye, we constantly are rubbing our eye to get it out because it's so sensitive and we get irritated. So we must know, like we must think how like a scratch would like feel. It's going to be enormously painful. So these lipids, known as DOPG in short, these aid the healing of the cornea. So it fast tracks it and aids in the healing of it. This research, or these lipids, were previously used to heal skin injuries. So they have been used on humans priorly, and they were observed in human cornea cells grown in a laboratory, as well as healthy mice and immune-compromised mice. This is because immune-compromised mice is reflecting like individuals that have a comprised immune system. So why is all of this important? This is because this drug does not have any lasting side effects, which a lot of the common drugs for this cause do. So that is very, very important, and the application can be so easy as an eye drop. So that is the main advantage of this drug. I haven't gone into too much detail, but I hope this covers most of your understanding for why this drug is so important. Thank you for listening. I hope you have a great day.